Okay, we are back with module video 5B and the third type of basic chemical reaction, which is combustion. Now there's complete combustion and incomplete combustion. We're going to start with complete combustion. So the third type of basic chemical reaction is combustion. A complete combustion reaction is when O2 is added to a compound containing carbon and hydrogen, producing CO2 and H2O. Okay, so complete combustion is when you add oxygen to a compound containing carbon and hydrogen, and your products are carbon dioxide and water. Here's an example. CH2O, so here is a compound containing carbon and hydrogen. It's added to oxygen, and it yields carbon dioxide and water. So that is an example of complete combustion. And it's not balanced. Let's balance it together. All right, carbon. One on this side, one on this side. Hydrogen. Two on this side, two on this side. Oxygen. Oh, silly me. It was balanced. I thought it was weird that I didn't balance the equation, or the book's example equation wasn't balanced. Anyway, always good to check by writing it out, right? So here's a balanced equation of a combustion example, complete combustion. Let's do another one. From your book, example 5.3 is on page 139. I'm going to erase this so that I have a little bit more room. Okay, example 5.3 says, a butane pocket lighter works by evaporating and then burning the liquid butane, C4H10, stored in it. Write the balanced chemical equation for this complete combustion reaction. So in this example problem, you are only given one reactant, but you are told what type of reaction it is. It's complete combustion. So you should be able to figure out, you should know the other reactant and the products. Complete. This is the complete combustion of butane. Okay, so we have C4H10, which is butane. In complete combustion, what is our other reactant? You got it. It's always O2. Yields, in complete combustion, what are our products? You got it. CO2 and H2O. Now make sure that you read this example in your book, because your book does the balancing a little differently. Again, using a fraction, you need to see which way you like doing it better. Using the fractions and figuring out that way with the book, or the way that I'm going to do it here. It's good to understand both. This one is a little tricky for balancing, as some of them will be. Okay, so carbon, we have 4 for the product side, and we have only 1 for the, 4 for the reactant side, 1 for the product side. We need this to be a 4, so 1 times 4, this is going to be our coefficient, equals 4. So now we have 4 carbons when we put the coefficient out front. Okay? Next is hydrogen. Hydrogen, we have 10 on the reactant side. Hydrogen, we have 2 on the product side. 2. We need this to be 10. So 2 times what is 10? 2 times 5. So 5 is going to be our coefficient out here. Okay? So now we have 10 hydrogens on our product side as well. Oxygen is where it gets a little tricky. Oxygen, there's 2 on the left, and on the right, there are 1, 2, we need to add them up with the coefficients. Okay, so there's 4 of this entire CO2 molecule. In each CO2 molecule, there are 2 oxygen atoms, so 4 times 2 is 8. there's 8 oxygens there, and over here we have 5 water molecules. In each water molecule there is 1 oxygen, so 5 times 1 is 5. So there's 5 oxygens represented in the water. So that makes a total of 13 oxygens on the right. Okay, so we have 13 over here, but there's not a number to do 2 times a whole number equals 13. This is where your book uses a fraction. However, I like to find the lowest common multiple. So the lowest common multiple of 2 and 13 is going to be 26. So if we want 26 oxygens on the left, we need to do 2 times what? That's right, 13. Way to go, you math geniuses. 2 times 13. So 13 is our coefficient out front here. All right? So now we have 26 oxygens on the left. We need 26 oxygens on the right. We have 13 right now, but our oxygens are split up into 2 separate locations. So it's a little tricky. But I know that 13 times 2 equals 26, right? So if I just double each of these coefficients and multiply the 4 times the 2 coefficient and the 5 times the 2, I'm going to end up with 26 oxygens. I don't know if I'm explaining this very well, but my students, we will practice these in class, okay? So I have 13, I want 26, I want twice as many oxygens, so I'm going to double each of my present coefficients. So instead of a 4 right here, I'm going to make this an 8. Instead of a 5 right here, I'm going to double that and make that a 10. Okay? So now for oxygen, I have 8 times 2 is 16, plus the 10 right here. 16 plus 10 is 26. So I now have 26 oxygens on the right, 26 oxygens on the left. However, I just changed these coefficients, so my number of carbons has now changed. I now have 8 carbons over here, so I need 8 carbons over here. 4 times what is 8? That's right, 2. So 2 is going to be my new coefficient out front here. So I have 8 carbons on the left, 8 carbons on the right. Hydrogen has now changed because I added that 2 coefficient out front. So I have 2 times 10, so now I have 20 hydrogens on the left. And on the right, I have 10 times 2. On the right, I have 20 hydrogens. And then, of course, our oxygens, which we worked so hard to balance, are still balanced at 26 on the left and 26 on the right. And so that is how you write the balanced complete combustion reaction for butane. Okay, for a combustion reaction, there's also something called incomplete combustion. Incomplete combustion is when a substance containing carbon and hydrogen burns in an environment where there is limited oxygen. Okay, remember, in a complete combustion reaction, you're burning something with carbon and hydrogen with oxygen, and you're producing carbon dioxide and water. In incomplete combustion, however, your oxygen runs out. So carbon monoxide, or carbon, is produced. Carbon produced like that we commonly call that soot. This can happen, or this does happen, in automobiles and in fireplaces. So you're producing carbon monoxide, which is poisonous, or you're producing excess soot and soot is getting into the air, or soot is gathering in your fireplace, which is why it's important to keep your fireplace clean. So I'm going to refer you to Module 5, which I know you are reading anyway, but make sure that you are reading and you are remembering and understanding the dangers of incomplete combustion, because like your book says, it's important for educated people to know the dangers of this.